This video tutorial is going to discuss independent and dependent quantities within a scenario. And how does it look on a graph? Where's the independent axis? Where's the dependent axis? So let's take a look. Let's first define independent versus dependent. So we have two variables in a relationship with each other. One variable depends on the other. Or you can say one quantity depends on the other. So your independent variable will be your x, your dependent variable will be your y. So if you think of this little chart here, your independent variable affects change in your dependent variable, not vice versa. The dependent variable doesn't affect change in your independent variable. Okay? So you think of what comes first. Some people like to think of that. I like to say to myself, take the two quantities, which one depends on the other. So let's look at some examples. So first example here is saving $20 per month. All right, so there's two quantities here. What are they? That's right. One is savings, how much you save, total savings, and your unit of measurement is dollars. Your other quantity is time. And what's the unit of measurement? Months. So now, does time depend on savings, or does your savings depend on time? That's right. Your savings is going to depend on time. So your independent quantity is time in months, and your dependent quantity is going to be your savings in dollars. All right, let's look at the next example. Driving 60 miles per hour. What are the two quantities in this relationship here? One is going to be distance traveled. Unit of measurement will be miles. The other quantity is going to be time. And it's going to be time will be in hours is the unit of measurement. All right. So does your distance traveled depend on the time? Or does time depend on distance traveled? What do you think? Well, your total distance traveled is going to depend on how long you've been driving, right? So if we look at the independent and the dependent example here, there we go, sorry. Independent quantity, I guess time in hours, dependent quantities, travel distance in miles. All right, one more example here. Let's look at losing 2 pounds per week. What are the two quantities? Well, one quantity is pounds lost, or weight loss, I guess would be better. So weight lost, and the unit of measurement is pounds. Right? And then the other quantity is going to be time, and this time the unit of measurement is in weeks. All right? So what depends on the other? Well, again, time is typically going to be your independent quantity in here. So losing 2 pounds per week, that means if you 5 weeks, you lost 10 pounds. 10 weeks, you lost 20 pounds. Sweet. All right. The dependent quantity is going to be your weight loss in pounds. All right, so now let's take a look at the graphs for these relationships. We said that the independent quantity is your x, and the dependent quantity is your y. So if you just do a little XY chart here, on this first one, x is months, there's your time in months, and then your y-axis quantity is your savings in dollars. And so you think about it, you go over 1 month, boop, $20. Go over another month, boop, $20. You're up to 40, right? Go over another month, boop, $20. You're up to $60 saved. And so on. Okay, driving 60 miles per hour, again, no traffic, you're just going to cruise 60 miles per hour. Well, 1 hour, boom, 60 miles. Another hour, boom, another 60 miles, you're at 120. Another hour, boom, another 60 miles, you're at 180 miles traveled, and so on. All right, losing 2 pounds per week. So this is total pounds loss, and this is weeks. So 1 week, we lost 2 pounds. Another week, we lost another 2 pounds. Another week we lost another 2 pounds, up 6 pounds lost. So this even though it's going up, you're losing weight because we've defined this as pounds lost. It keeps getting more and more and more and more. It's not your total body weight being measured here. Otherwise, that'd be decreasing. All right. Let's look at some other scenarios here. So here we got a 50-gallon fish tank. It's being drained at a rate of 1/2 gallon for every 2 minutes. So I want you to think about what's the independent quantity, what's the dependent quantity, and is this graph going to be, is it increasing or is it decreasing? All right, so our two quantities are going to be water in the tank, and that's measured in gallons, and that's going to be dependent on the time, which is going to be time in minutes, right? And so what's going on here is you start off with 50 gallons in the tank, and it's going to go down 1/2 gallon, 2 minutes, right? Down 1/2 gallon every 2 minutes is what's going on here. So it is decreasing in this example. All right, again, you can see independent quantity on the x-axis, dependent quantity on the y-axis. One more example. A jet takes off and climbs at a rate of 1,000 feet per minute. Is it independent or dependent? Is our graph going to be increasing or decreasing? All right. So independent quantity is going to be our time in minutes. Got a little typo there, see? And then our dependent quantity is going to be the height of plane in feet. Height of plane in feet. So what's going on here? Jet takes off, 1,000 feet per minute. So 1 minute, boop, 1,000 feet. Another minute, boop, another 1,000 feet, and so on. Going up, 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 and away. And obviously this is increasing. All right. That's it for independent and dependent quantities. We'll be doing a lot of practice with these in class.